Today we will study Yang-based data modeling. The Yang is ITF standard document RFC 7950. The Yang version 1.1 data modeling language. You can click this link, you can get the document. The Yang is stands for yet another next generation Yang data model. This is there are model language used to model compilation and state data manipulated by the network compilation protocol called the netcomp, RFC 6241. It is also used to state the netcomp remote procedure called RPCs and netcomp notifications, notify some events. That is, it is used to model the operations and content layers of netcomp. The objectives of Yang document describes the syntax and semantics of the Yang language. It explains how the data model defined in Yang module is represented in the extensible markup language called XML. It explains how the count operations are used to manipulate the data. So we have a bunch of terms in terminology. So you can refer to those one. For example, any XML is data node that can contain a known chunk of XML. So any type of Yang data type can be facilitated. Okay. So I will explain during this lecture. I will explain the forms. Okay. So you can refer to them. So Yang functional overview. Yang is a language used to model data for the netcomp protocol. So it defines a hierarchy of data that can be used for netcomp or lastcomp operations. Okay, including compilation, state data for monitoring of system, also remote procedure calls, RPC, and event notifications. Okay, Yang models the hierarchical organization of data as a tree. Each node has a name and either a value or a set of child nodes. Also, augmentable hierarchy. One module is allowed to add data nodes to the hierarchy defined in another module, which means we define a Yang module, so this module can be attached to another the module, so we can reuse this Yang module as code reuse. This augmentation can be conditional with new nodes appearing only if certain conditions are met. So we'll see. Constraint enforcement. Yang models can describe constraints to be enforced on the data. They restrict the appearance of or value of nodes based on the presence or value of other nodes in the hierarchy. These constraints are enforceable by either the netcomp client or the netcomp server. The data types. Yang defines a set of built-in data types, so Yang already have like a keyword, the types. Also, we can define using type that, like C language. It has type mechanism through which additional types may be defined. I mentioned the type that. Derived types can restrict their base types, a set of values using mechanisms like range or pattern restrictions. It can define usage conventions for use of the derived type, such as a string-based type that contains a host name. So grouping is a very useful structure. This is for reusable grouping of nodes. Actual instantiation of the grouping can refine or augment the node grouping itself is not instantiation of a variable. Okay. List is actual like a structure in C language. List entries are identified by keys. So we have one key like a database key in record. Lists may be defined as either sorted by user or automatically sorted by the system. Another concept is Yang independent notation. It is called in. So in is actual instantiation of compilation based on the Yang. So Yang modules can be translated into an equivalent XML syntax called the Yang independent notation in, like XML file. This translation allows applications using XML parsers and extensible style sheet language transformations XSLT script to operate on the module. Basically, given Yang model, we can translate into in. So Yang and in is in Korean Yang Okay, this is positive. This is negative. Lossless conversion between Yang and in. The goals of Yang supports the translation from high-level data modeling to this one is we can say to translation to uh, low-level bitwire encoding. Okay, so okay, so a leader of a Yang module can see the high-level view of data model with understanding how the data will be encoded in the backup operation. So Yang is an extensible language allowing extension statement to be defined by standard bodies, vendors, and individuals. So we can easily extend. So basically, uh, given some Yang module, you extend by your own purposes. Yang aims at the problem space to allow expression of an account data model rather than arbitrary XML documents or arbitrary data models. The data model described by Yang are designed to be easily operated upon by netcomp operations. So in the past, SMPL, simple network management protocol is used to monitor and manage for network system. So Yang is compatible with SMMP. So Yang maintains compatibility with SMP, SMI version 2 structure of management information version 2. So SMI version 2 based meet management information based module can be translated in the Yang module for read-only access. But a Yang case allow compilation write and read together, but SMPL just for read only. Device management, like netcomp, Yang target smooth integration with a device native management infrastructure. This allows implementations or implementers to leverage their existing access control mechanism to protect or expose the elements of the data model. So we have a concept module and submodule. The module contains three kinds of statements, such as a module header statement, revision statement, and the definition statement, three parts. So a module header statement describes the module and give information about the module itself. Okay, it introduces the model, okay, like who made this model. The revision statement give information about the history of the module, the revision history. The definition statement actually the body of the module where the data model is defined. So module may be divided into submodules. So we can make multiple submodule like some abstractions and module concept in objective-oriented programming based on the needs of the module owner. The external view remains that of a single module regardless of the presence or size of each submodules. Also, we have included a statement allows a module or submodule to reference the material in submodules. Okay, and also the import statement allows the references to material defined in other modules. So we can reuse the defined data from other modules. So we have a basic data model data types here. So the lib nodes, lib list nodes, container nodes, and list okay nodes. Okay, so we can look at one step at a time. So lib node. This one is you can see uh, kind of the simple data, integer or string. Okay, so we define lib. So in the Yang is a kind of tree structure. So tree is the root, is usually the module. Okay, um, some name, also container. Okay, so and then at the bottom has the lib. So lib data structure can be defined like this. Okay, lib host name. The type is a string. Okay, and the description is just a comment. Okay, not actual code. Host name for this system. So we can this is a Yang part. This is the in the XML part. So host name. So this is a header tag. This is a tail tag. Okay, XML. This is host name, and then here body we have value my dot example.com. List a lib list is a kind of a repetition of libs. So we can define lib list domain of search. Okay, this is the type is a string. This is a list of domain names to search. So this lib is just the one instance, but the lib list case we can multiple domains list of domains. Okay, the container is used to group related nodes in a subtree. Okay, so we can make some constant instantiation of variable. So system login. So this is a kind of okay instantiation. So system a login case we make okay here system and login. So and then inside the container. So container actually include the variable. So this is a kind of extension of structure data. Okay, variable. So the message will have this good morning actual message. List nodes. List node is like structure in C or C++ or record instance in Pascal programming language. Okay, so each entry is uniquely identified by the key of lib value. Example here, the young user. So key variable is a lib node this name, and it consists of a name, full name, class. Okay. So here we can define the list node. Okay, here. Okay. So name, full name, and the class. Okay. So we have a multiple, right? Because this is a kind of structure. Okay. So example of a cool young module here. So module example version, and this is the head part, okay, revision part, and the actual data description definition part here. Okay. So example system, the system container actual instantiation of a variable this young module, and consists of the lib, okay, hot name and the lib list. Okay, the domain search, okay, list of the domain names. They include server container. So login. Login consists of messaging and the user. User also list node. I mentioned this is structure of a C. So the key value is variable is name. This list node consists of lib name, lib full name, lib class name. So state data case not configured. So usually tagged with config process. So in that case, netconf case just can get status data using get operation rather than get configure, get configure actual live operation. So, for example, state data case, we have an interface like a network interface, name, speed. So, observer speed is configure. First means this is just observed, not actually configured using edit configure or get configure cannot use just get operation used to get. Okay. So, Yang has many built-in types like C language. Okay. So binary bits, Boolean, and integer, 8-bit, 16-bit, and unsigned integer, and string, lib lab. Lab is a reference to already defined lib instance. Okay. And this is union, choice of a member type. So we can define using a type def like C. So we can type def, right? So percent define the assigned 8-bit. Okay. Also, we can define a range. So this 8-bit is 0 up to 250, right? So the range is here, sub range 0 up to 100. Description is a percentage. Okay. And then the lib is actually defined. This is a lib node, right? And this is a percent type. So XML case, we can make completed, right, in the 20. But the 101 is not because the range is out of range. Okay. Also, the Yang has a derived type based on this built-in types. Okay. So using type def. So counter 32, counter 64 for counting, something like that. Okay. And then also the IP button 6 flow, IP button 4 address, IP button 6 address, IP button 4 prefix, IP button 6 prefix for network prefixes. Okay. So example is IP version 4 prefix using here pattern. Okay, string here using pattern. We have kind of the regular expression. Version 6 case also we can define using this kind of pattern as a regular expression. So the grouping. So grouping is used to define the usable node groups. So this is not actual installation of variable. This is a kind of a schema point of view, just grouping. So we make a group like a target some machine consists of IP address and the port number. Okay, here. So address is type INET. IP addresses. INET is a module. Okay, so we can using this one. INET and the actual this is a variable. So sub variable is using INET. Also port number is a member variable here. So and then here we make the instantiation here. So container destination used. Okay. So it this container the type is user target case. This lib address port is embedded. Okay, so we don't repeat this type. Okay, lib and lib address, lib port. Just using this. For example, source we can make a container source and then container source something like that, and they use it target case is the same. Okay, UCZ. Okay. So the peer here, peer and the destination, this destination of the variable XML in. So and then here address port we can reuse. Okay, using grouping. So here grouping as can be defined, allowing certain statement to be overridden. Okay, so using define. Okay. So here the connection, okay, source, the target addressing, and then we using a target here, address port here, and the use case we can define command, right? The address port, okay. Description is okay. We can specify clearly source IP address, source port number. Also destination target case using define address port description can be updated like this. Okay, previously just the target IP address, the target port number, so can update like this. And choice is like some switch case statement in C. So the choice is a kind of switch statement. The case is a case a statement select. Okay, um, during the selections. Okay. So here, the container pulled and the snack. So snack is a kind of switch statement. The snack value depends on snack value, and then it is sports, arena, or light. Okay, and depending on, and then we can select this case, the XML case just the pressure and beer, pressure and beer, or just the chocolate, but not both. Okay, because the choice statement case just schema point of view structure. Instantiation case is just one of them. The one case variable should be selected. And next concept is augment. So extending data model. So using augment, we can insert additional node into data model, including both current module and its submodule, or an external module. So for example, this is used for vendors to add vendor-specific parameters to standard data models into a proper way. So the augment statement defines the location in the data model hierarchy, okay, using the kind of path, okay. We can see the example later on. And the when is condition, okay, when the new nodes are found. So here, the system augment the system login user. So this one. So refer to slide 23 here, example system, right? So the system container, top container is the system, and then the server container is the login, and then the variable class, right? System slash login slash class. This is specified variable here. Here. Okay. So system login variable. So if class user, so users the class variable is a field case, we include this UID. The range is 1,000 up to 30,000. Okay. So example here. So the list W pulling list lead drop out. Okay. So class variable is not field, right? So in that case, we can include the user UID. So the others UID we can define like this. But here, field, right? In that case, we cannot include, right? So if we include this one, it is invalid. Okay. And then let's move on to RPC. RPC is used to specify netconf operations name and input parameter and the output parameter. Okay. So here RPC. So in Yang, activate the software image input case the image name type is a string, or the output case lib status type is string. So netconf we see. So this is RPC request or RPC remote control request remote control. This one response. Okay, reply. Okay. So here the active software image here, right? And then so we have this name, and here active software image here, right? So name. Okay, so RPC request. So input is a request. Okay, so the parameter is the image name. So image name we can okay using RPC. So the output case RPC reply. Okay, so in that case, the status variable is used to the output parameter. Okay. So, and then notification is used to deliver the event as a notification. Okay. So, their definition statement are used to model content of notification. So, you can say the event like some attack, like security attack. So or link pair here. So in that case, the interface name and the interface admin status, interface admin operator status. Okay. So netconf case, this kind of event, the happen case, the event okay time here, and then and the link period here, right? Link period notification is delivered, right? Including this if interface name, interface admin status, interface the operator status like this. Okay, so this kind of information can delivered. So Yang tree diagram is a simplified graphical representation of a Yang data model. So this one also we can define Yang module. The Pyang tool can be used to construct this one automatically. So RFC 803040 Yang tree diagram describes the current syntax used to Yang module tree diagram. So example of system previously we saw, right? So this example Yang module can make this one. So you can see module name example system, and then here container system, and then it includes host name, and the domain search. Okay, star indicates a list. Question mark is just list node. Okay, the login. So login is another container. So lib, okay, message question mark, and the user star case. This is multiple instance. This is we can make okay list. Okay, so like so we make list and the user and then full name and class name here. Okay. So previously the status flag, right? Status flag. So status is plus x or the plus right here, usually plus. So is a foreground current. Okay. Usage. X is a duplicate, not okay, use it okay, anymore. And obsolete is similar, obsolete, the older one. So flag case, one of them, right? So read write, this kind of authentication, RPC. So this is okay, flags, okay. Also name and op. So name here, name, and this is an option, okay. So name is the name of node, okay. And the op case, question mark, this we saw the asterisk. So this is optional lib, okay, not. So key lib case, there is no option here, right? So question mark is optional, okay, no, okay. And the star asterisk star is for a lib list or list, okay. And the type and the if features type case, the name for libs or lib list. Okay, so if the type is lib lab, okay, reference to lib, the type printed like this, the target arrow and target. So target is the lib reference pass. Okay, with the prefixes removed if possible, or if lib lab. Okay, if features is a list of features. This node depends on printed with a curly, like curly bracket and question mark. Conclusion, in this class, we learned the following, like the overview of the Yang 1.1 data model language in RFC 7950. Yang is the ITF data model language. Yang defined variables and procedures for RPC for laptop automation using netcom RPC 6241 and LATCOM. This one is operating XML HTTP protocol RPC 8040. Okay. If you have a question, please let me know. Thank you for your attention.